In this video, we are going to start about the exterior angle of a triangle. So let's start in our geometry session, and this video is for the theorem 8. Now you see the about theorem 8, and this theory is said if one side of a triangle is produced, then the exterior angle is get greater than either of the interior opposite angles. So this means first we are draw a diagram, and this is a ABC triangle, and this BC line is the produced a line which is called the BD line, and this AC line is the produced, this is called the AG line. And you see here this this E point is the middle point of this AE line or AE side of this ABC triangle. Now let's see our theorem. So if one side of a triangle, this one side of a triangle means this BC. So this BC is the one side, and this BC is the produced a line which is called a BD line. BD line, then the exterior angle is, and this exterior angle means the ACD. This ACD angle is the exterior angle, and it is the greater than either of the interior opposite angles. Means its exterior angles opposite angle is the two angles. One angle is the CB A angle, and another angle is the BAC angle, and this exterior angle should be greater than either of the interior opposite angles. Means it should be greater than with this ABC angle, or it should be greater than with this BAC angle. So this is our problems, or this is our theorem, and we have to prove. Now you see we have written here this theorem. Again, I am elaborating these things. Now you see here, let A be C a triangle. So here this is a ABC triangle. This triangle is the ABC triangle, and it is the BC is the produced to D, means this is the BD is the straight line. This is the produced, and it is required to prove that the exterior angle ACD, this angle should be greater than with this BAC angle or this ABC angle. Okay, and this is the opposite of this exterior ACD angle. Now we have drawn some lines here. So we have taken a E point here. This is a E point, and this E point is the middle point of this AC line or AC sides of this ABC triangle. And we have joined this BE, this line, to produce it to F. Means this line, this BE line, we have extended up to this A point. So that this BE, this line, this BE line is equals to EF line. And we have joined here this A point to C point by this line. So this is the FC line. Now, how we will prove this theorem? So here these are two triangles have been formed. This one triangle is the AEB triangle, and another triangle is the CEF triangle. This is the two triangles have been formed. If we prove these two triangles are equal in all respect, then we can easily prove that this angle, this ECF angle, is the equals to BAE angle. So how we will prove that? So now you see here, this is the AE. This is E is the middle point. So this AE equals to EC, and this BE equals to EF, because we have drawn. And these two angles, this AEB angle is vertically opposite angle CEF angle. Now you see these two sides and one angle is equal for these two triangles. So we can say these two triangles are equal in all respect. And we can say this BAE, this angle is equals to FCE. This is, and so that we can say this is the angle ACD. This total angle ACD is the greater than of this ACF. This ACF. Here we can easily understand this angle is the less than this ACD angle. So we can say this ACD angle is the greater than of this ACF angle. And so that we can say this ACD is the greater than is the BAC angle. Okay. So now let's come to this another proof for this ABC angle, for this angle. Now this is the same way we can prove this. This E is the middle point of this BC line or BC side, and we have joined this AE line, and this is the produced to F, and this EF is equals to AE. So means this AE equals to EF, and these 2 points F and C we have joined by this FC line. Now we can easily find out there is a two triangle is here. This one triangle is the ABE triangle, and another triangle is the EFC triangle. And if we prove that these two triangles are equal in all respect, so we can easily prove that this angle is equals to this ABE angle is equals to ECF angle. Now here we see here this is the BE equals to EC, because this E is the middle point of this BC sides, and this AE equals to EF, because we have drawn here this AE equals to EF, and this angle, this is a vertically opposite angle FEC. So FEC equals to angle AEB. This is a vertically opposite angle. So these two angles are equal. So here the two sides and one angle are equal for these two triangles. So these two triangles are equal in all respect. Means this triangle ABE equals to triangle FEC or EFC. Okay. So that we can say this angle ECF equals to angle EBA. Now we can say this is the ABC and this is the total BCF. So angle BCF equals to angle ABC angle. So this angle, this BCG, so this angle BCG greater than this angle ABC angle. Okay, and these two angles are vertically opposite, so we can say angle ECG equals to angle ACD. So we can say easily this angle ACD, this angle ACD is greater than angle ABC. Now I think everybody can understand this theorem 8. Now comes to the which theorems or which is come from this theorem 8. So this first is the corollary 1, and this corollary 1 is said any two angles of a triangle, any two angles of a triangles are together less than two right angles, because these three angles, if we add three angles, so it should be equals with the two right angle. So it is, we can easily prove that these two angles is should be less than the two right angles. Now you see here this total three angles, this total three angles should be the two right angles. So this two angle maybe, or these two angles maybe is equals, or actually these two angles should be the less than of two right angles. Okay, so let's come to the corollary 2. This corollary 2 is said this every triangle must have at least two acute angles. So now you see this every triangle must have at least two acute angles. If I draw a triangle like this is a right angle, or maybe we have drawn triangle like this is a obtuse angle. So this two angle is the acute angle, means this angle should be less than 90 degree, and this angle should be less than 90 degree, and this angle should be less than 90 degree, and this angle should be less than 90 degree. Again we have write down here this one angle is the obtuse or right angle, then each of the other angle must be less than a right angle, so that it is the acute angle. Now let's see the corollary 3. So only one perpendicular can be drawn to a straight line from a given point outside it. Now you see here is the AB is the line, and this P is the point which is the outside of this AB line, and we have drawn here a right angle. This is called the PQ, and or perpendicular. Okay, and this is the R. Again we have tried to draw a right angle. This is called the PR. Now you see here this the PQR triangle have been formed. So this angle PQR and angle PRQ right angle, which is impossible because more than three angle have been formed here, and this is a triangle. So these two angle should not be the right angle. Okay, only one angle should be the right angle. So again this corollary have been proved. So this end of this theorem 8. This is my request. Please see my previous theorem video and problems and solution, then you can understand very easily all theorem. So thank you.